Hi, welcome to StatStuff. I'm Matt Hansen. In a previous lesson, I briefly described distributions, but in this lesson we'll dig a little bit deeper into describing them and some of their characteristics. It may help to review the lesson on data types as a prerequisite for the content I'll be reviewing in this lesson. So let's begin by defining what is a distribution.
Well, a distribution is created by plotting or distributing a set of data along some sort of numerical scale. Distributions are only going to be built off of using a continuous value, not a discrete value. Then the more data that's plotted on that scale, then the more of a shape those data points will display, or you'll start to see some shape that's developing from those data points. The best way to illustrate, I think, is to use something like a dot plot. Now, a dot plot, if you wanted to build one, could be done within Minitab by going to the Graphs menu and selecting dot plots. So just as a purpose of an illustration where you start with some sort of data, this is a simple dot plot here, where if you plot these data points, they might fall on this type of scale like this. The more data that you add, they start to fill in into these different columns here. And you continue to add more and more data. And the more data that you're adding, you're seeing it's beginning to take some sort of shape. They're starting to get a little bit larger in each of these columns and starting to take on some shape. And finally, with the more data points you have, as you lay it out, it's kind of looking like a distribution, like a bell curve of how you might normally see a distribution. So this is just showing that the distribution will generally be some way that is on a scale, how all those data points are distributed on the scale. And this dot plot hopefully is some illustration to get us there.
If you hadn't already noticed, dot plots can be a bit limited, so let's talk about some of those limitations.
Well, despite seeing the shape of a distribution showing up with the dot plots, there are a lot of limitations of the dot plot itself. For example, not all the data points necessarily stack so neatly into columns like in the dot plot example that we have, but because if you have a few data points, it might work well in using a dot plot, but if you're going to have data points that are more than 50, then the dot plot itself is going to be very limited and a lot less practical at displaying all those values. So if you have something that has more than 50 data points, you're probably better off instead using a histogram. And by default, I generally prefer to use a histogram anyway. So a histogram is going to be a way that you can represent the same kind of data and a whole lot more of the data, but it groups the data instead into bins instead of into unique values and showing each of those unique values as a separate dot like in the dot plot itself. So by stacking into bins using percentages within each of those bins, it comes to a shape that's a better representation when you have a whole lot of data to work with. Now if you're going to build a histogram, like in Minitab, you would go to the Graph menu and select Histogram. So here's an example of what one looks like. And this is where we're taking the dot plot and now we're taking the same data and now we're representing it into this histogram here that we're seeing. So in this format here, here's some of the elements. Minitab tries to create this bin like this, but it also tries to fit a line in here that represents the curve or the distribution of representing how the data is spread across this or how it's distributed across the scale that we're looking at within our data set. Some of the other elements in here is the vertical axis represents the frequency, or that is the percent of the data points representing each bin. So the one that's right around here is about 25% or so of the data points fall within this particular bin. And then this one, it's nearly about maybe 38% or at least 35% of the data points fall within this bin, and obviously all of them will add up to 100% representation. But it shows how those the frequency or the proportions are spread out across this whole scale, or how they're distributed across the scale. Each of these bins will include all the data points that fall within a specified range. So these are the data points that fall within some certain range in here. It's not necessarily always going to be the data points that fall exactly at this point on the scale, but it usually will be grouped together. Since, again, we're talking about continuous values that can be infinitely divisible and could go on to infinity as well, you're going to have a lot of variation in your values, not necessarily exact values like we represented it here in the dot plot itself. But when you have those groups of values where you have some sort of range, again, the bins are going to represent those different ranges like that. Now across the horizontal axis, this represents the actual scale where all the data points are distributed, or where they're falling across this type of scale here.
Okay, so now let's talk about two characteristics that describe the shape of distributions.
Well, distributions can be described according to two different characteristics, that is, its central tendency and spread. So in this case, let's talk about central tendency. It's referring to the location on the scale where the majority of the data points are concentrated. That is, the central area where most of the data points tend to fall is how I like to think of central tendency. So for normal distributions, it's going to be the mean, which is also the same thing as the average, that we'll use as a measurement for central tendency. Now for variation or spread, this is referring to how dispersed the data points are, that is how spread out they are across the scale, or at least spread out from the central tendency. So for normal distributions, the standard deviation is the measurement that we would use for measuring variation. So if we have a scale like this with this type of distribution here, we can see that we can have several types of distributions that are spread out on this particular scale. And we might have a mean that's drawn here by the dotted line. Well, this mean, this center point, is the center point as defined not by the scale necessarily, but defined by these three different distributions, where all three of them seem to have the same mean, even though the distributions all look different from each other. So in this case, the central tendency is what's represented here. It's the midpoint, again, where the majority of the data points tend to fall, that central area where they tend to fall. Whereas the variation or spread will be represented by how spread out each of these distributions are, how spread out the data points are from this center point. Now, a couple other things to consider is the kurtosis, and a couple of types of kurtosis and how we would describe the distribution itself. So it's a measurement of the shape of the peak near the mean of the distribution, that is how peaked or not peaked the central point is around each of the distributions. Now there's two types here. A distribution that has a high or positive kurtosis is called leptokurtic. That is where it's going to have a sharp peak somewhere around the mean, as opposed to a distribution that has a low or a negative kurtosis, what's called platykurtic, where it's going to appear flatter. That is more like a plateau, where it's laid out and it has less of a peak around the mean. Now with the distribution examples that we have up here, as far as the ones that are leptokurtic versus the ones that are platykurtic, well, in this example, the red distribution might be more platykurtic. It's a little bit flatter, versus this green distribution, which is more leptokurtic because it has more of a peak in it.
All right, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way.
Well, if you have Minitab, what I'd like you to do is to open up the Minitab sample data file that's been provided on the StatStuff website. And using that data file as a source, try to first create a dot plot using metric A and metric B in the data. Also then try to create a histogram for the metric A as well as for metric B. And then also I'd like you to try to ask yourself which of those metrics appear to be more leptokurtic and which one appears to be platykurtic in its distribution. Now, having worked with that data, what I'd like you to do is try to pull some historical data for at least two different metrics that you use in your organization. And if you can, try to get enough data points where you can create some good distribution. So you might want to pull it on a daily level for at least maybe a couple months or more, or if it's at a weekly level, maybe for a much more extended period of time. Either way, you want to try to aim for getting a good at least 30 to 50 data points, if not more, if possible, so that way you can draw these distributions. And try asking yourself the same questions and following the same process above for creating a dot plot and then also creating a histogram and determining from that whether you have a leptokurtic or a platykurtic type of distribution.
Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.